July 17, 1943. 23,000 feet above the Dutch coast, Captain Robert Johnson's P-47 Thunderbolt clawed for altitude as yellow-nosed Focke-Wulf, 190 seconds dove from the sun. Johnson craned his neck backward, trying to spot the second attacker through the narrow slit of plexiglas behind his head. The razorback fuselage rose like a wall behind the cockpit, blocking everything aft of his 3 o'clock position. He couldn't see them. That was the problem. In the sprawling air battles over occupied Europe, American pilots were dying not because their aircraft lacked speed or firepower, but because they couldn't see death coming from behind. 4,000 miles away, in a cramped engineering office at Republic Aviation's Farmingdale factory, Alexander Kartveli studied combat reports that documented a problem no amount of armor or horsepower could solve. The P-47 Thunderbolt, his masterpiece of American engineering, was getting its pilots killed by its own fuselage. Design. The tall razorback spine that housed the aircraft's radio equipment and provided structural strength had created a blind spot so severe that Luftwaffe pilots had learned to exploit it with lethal precision. German fighter tactics now specifically targeted Thunderbolts from the rear quarter, knowing American pilots couldn't see the attack until cannon shells were already shredding their wings. But Kartveli had seen something in reports from Royal Air Force pilots flying Hawker Typhoons fitted with a revolutionary new canopy design, a seamless bubble of molded plexiglas that curved upward from the fuselage line, providing visibility in every direction. The concept seemed impossible for the P-47. Cutting down the massive razorback would compromise structural integrity, destabilize the aircraft, and require retooling production lines that were already churning out fighters at record pace. Every engineer at Republic said it couldn't be done. The British Canopy was designed for a different airframe with different weight distribution. Adapting it to the Thunderbolt would be reckless, expensive, and dangerous. Kartveli picked up his pencil and began calculating load stresses anyway. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Thunderbolt had emerged from Kartveli's drafting board in 1941 as an answer to a desperate problem. American fighter doctrine, built around lightweight interceptors with modest armament, was collapsing under the weight of combat reports from Europe. German and British fighters carried heavy cannon, operated at extreme altitudes, and absorbed punishment that would tear apart existing American designs. The Army Air Corps demanded a fighter that could escort bombers into the heart of the Third Reich, survive concentrated fighter attacks, and maintain combat effectiveness at altitudes above 25,000 feet where thin air defeated most existing engines. Kartveli's response defied every principle of fighter design. Instead of pursuing lighter weight and higher maneuverability, he built the heaviest single-engine fighter in history around the most powerful radial engine America could produce. The Pratt & Whitney R2800 Double Wasp generated 2,000 horsepower through 18 cylinders arranged in 2 rows, driving a massive 4-bladed propeller. 8 50-caliber machine guns, 4 in each wing, provided firepower that no German fighter could match. Armor plating surrounded the pilot's seat and protected critical engine components. The entire package weighed over 12,000 pounds at takeoff, nearly twice the weight of contemporary fighters. The aircraft's most innovative feature remained invisible to pilots. Kartveli had designed the P-47 around its turbocharger system, positioning the massive General Electric unit in the tail and running ductwork through the fuselage belly. This unconventional layout required raising the fuselage spine to accommodate the ducting, creating the distinctive razorback profile that would later prove so problematic. But the system worked brilliantly. Where other fighters gasped for air above 20,000 feet, the Thunderbolt maintained full power output to 30,000 feet and beyond, giving American pilots altitude superiority over every German interceptor. Production P-47Bs reached operational units in early 1943, and pilots immediately recognized both the aircraft's strengths and its critical weakness. The Thunderbolt could absorb catastrophic damage and continue flying. It could dive faster than any fighter in the world, reaching speeds that compressed control surfaces and made enemy pursuit impossible. Its 8 machine guns could tear apart German fighters with a single burst, but its rear visibility was so restricted that pilots developed elaborate weaving maneuvers just to clear their tail sections during combat. The problem became lethal during the first months of combat operations over Europe. On April 15, 1943, Major Don Blakesley led the 4th Fighter Group's first engagement against Luftwaffe interceptors over France. The mission briefing had emphasized maintaining formation discipline and clearing tail sections through coordinated visual coverage. But combat rarely followed briefing room predictions. German fighters attacked from multiple directions simultaneously, forcing individual Thunderbolts to break formation and engage in turning fights where rear visibility meant survival. Lieutenant James Stewart found himself pursuing a Messerschmitt 109 through a climbing turn when tracers flashed past his canopy. He jerked his head around, trying to spot the attacker through the narrow rear quarter windows. Nothing visible. The tracers intensified. Stewart threw his Thunderbolt into a violent roll, trading altitude for speed in a desperate dive that carried him through 8,000 feet before the pursuing Focke-Wulf broke off. Back at base, maintenance crews counted 47 holes in Stewart's aircraft. The German pilot had maintained firing position for nearly 30 seconds, while Stewart frantically searched blind areas he couldn't see from his cockpit. Combat losses mounted as Luftwaffe pilots refined their tactics. German fighter doctrine emphasized attacking from the American blind spots, approaching from the rear quarter where the P-47's razorback completely blocked visibility. Intelligence reports documented German training protocols that specifically taught new pilots to exploit this weakness. The mathematics were brutal. American fighter pilots were being shot down not because they lacked courage or skill, but because their own aircraft prevented them from seeing threats that experienced combat veterans could have countered. Kartveli received these reports with growing frustration. He had designed the P-47 to protect its pilot through armor, firepower, and structural strength. But protection meant nothing if pilots couldn't see attackers positioning for the kill. The razorback fuselage that accommodated the turbocharger system had become a death trap for the men flying his aircraft. Engineering solutions existed, but none were simple. The British Malcolm Hood offered modest improvement by raising the canopy profile, but several P-47 seconds fitted with Malcolm Hoods in the field still suffered from restricted rear visibility. The solution required something more radical. British aircraft designers working on the Hawker Typhoon had developed a true bubble canopy that provided 360-degree visibility. The design eliminated the traditional framed greenhouse canopy entirely, replacing it with a single piece of molded plexiglas that curved seamlessly from the windscreen to a point well aft of the pilot's seat. To accommodate this canopy, Hawker's engineers had cut down the Typhoon's fuselage spine, lowering it dramatically behind the cockpit and creating an entirely new structural configuration. The transformation in combat effectiveness was immediate. Royal Air Force pilots flying bubble-top Typhoons reported they could spot enemy aircraft approaching from any angle, track multiple threats simultaneously, and maintain situational awareness during violent combat maneuvers. The psychological impact proved as significant as the tactical advantages. Pilots who previously spent combat missions constantly checking blind spots could focus on offensive engagement, knowing they would see any threat developing in time to react. Kartveli obtained detailed technical specifications for the Typhoon bubble canopy in late spring of 1943. The design appeared deceptively simple: a single sheet of optical quality plexiglas, heated and formed over a precisely machined mold, creating a transparent dome that provided unobstructed vision in every direction. The engineering challenges lay not in the canopy itself, but in the structural modifications required to support it. Cutting down the P-47's razorback fuselage would eliminate the structural continuity that tied the empennage to the center fuselage. The aircraft would require entirely new internal framework to maintain torsional rigidity. Wind tunnel testing would be essential. The razorback provided significant directional stability through its keel area. Removing that structure might create yaw instability that would make the aircraft uncontrollable during high-speed maneuvers. Republic's aerodynamics team calculated that cutting down the fuselage would reduce effective keel area by nearly 20%, potentially requiring a larger vertical stabilizer or auxiliary fins to maintain directional control. Production considerations complicated the engineering problem. Republic's factories were producing P-47 seconds at unprecedented rates, with aircraft rolling off assembly lines in Farmingdale and Evansville every few hours. Implementing major fuselage modifications would require retooling both facilities, training workers on new assembly procedures, and potentially accepting production delays at the exact moment when 8th Air Force commanders were screaming for more fighters. The financial cost would run into millions of dollars. The time cost could be measured in American lives lost while waiting for improved aircraft. But Kartveli had fought institutional inertia before. When Army Air Corps procurement officials questioned his radical turbocharger layout, he had proved its effectiveness through wind tunnel data and flight testing. When critics argued the P-47 was too heavy to be an effective fighter, he had demonstrated that weight properly distributed became armor and firepower rather than liability. The bubble canopy would require the same methodical approach. First, prove the concept through a single modified prototype. Second, demonstrate superior combat performance. Third, present data so compelling that procurement officials had no choice but to approve production modifications. In July of 1943, Kartveli selected P-47D-5RE serial number 42 to 8702 for conversion to the bubble canopy configuration. The aircraft had completed initial flight testing, but had not yet been delivered to operational units, making it available for experimental modification. Republic's engineering team began by carefully removing the razorback fuselage section, cutting through metal-stressed skin and internal framework, with precision that preserved the aircraft's primary structural members. The cuts extended from just aft of the cockpit to a point 30 inches behind the pilot's headrest, eliminating nearly the entire fuselage spine. New structural members replaced the removed sections. Internal bulkheads reinforced connection points between the forward fuselage and empennage. Additional longerons ran along the reduced fuselage sides, providing continuity that the razorback had previously supplied. The modifications added minimal weight while restoring structural integrity that cutting operations had compromised. The resulting fuselage sat dramatically lower behind the cockpit, creating what engineers called a clear view configuration. The bubble canopy itself came from a Hawker Typhoon production unit, carefully fitted to the modified P-47 fuselage through custom mounting hardware. The British canopy measured slightly wider than ideal for the P-47's fuselage width, requiring careful shimming and sealing to prevent air leaks at high altitude. But the fit was adequate for testing purposes, and the resulting visibility transformation exceeded even optimistic projections. The pilot could now see directly behind the aircraft without obstruction, track targets through complete rolling maneuvers, and maintain visual contact with formation members during any flight regime. The modified prototype, designated XP-47K, rolled out of Republic's experimental hangar in late July. Chief Test Pilot Mike Ritchie conducted the first flight, taking the aircraft through a conservative test card that evaluated basic handling characteristics and structural integrity. His report documented good control response in all axes, no unusual vibrations or structural concerns, and visibility that exceeded any fighter he had previously flown. More importantly, initial stability testing revealed no serious yaw instability. The reduced fuselage spine had decreased directional stability slightly, but not enough to compromise controllability. Subsequent test flights explored the XP-47K's performance envelope, pushing the aircraft through high-speed dives, maximum G-turns, and violent aerobatic maneuvers that stressed airframe and structure. The bubble canopy remained secure through all testing, with no cracking, crazing, or structural failures. Wind noise increased slightly compared to the razorback configuration, but not enough to interfere with radio communications or pilot concentration. The reduced fuselage drag actually improved maximum speed by approximately 3 miles per hour, a modest but measurable benefit. Combat evaluation would provide the real test. Kartveli arranged for the XP-47K to be delivered to 8th Air Force Headquarters in England for operational assessment. The aircraft arrived at High Wycombe in September of 1943, where experienced combat pilots from the 56th Fighter Group volunteered to evaluate its capabilities against standard Razorback P-47 seconds. The test protocol called for head-to-head mock combat between the bubble top and conventional aircraft, with engagements photographed from chase planes to document tactical advantages. The results were dramatic. Pilots flying the XP-47K could maintain visual contact with attacking aircraft through maneuvers where Razorback pilots lost track of their opponents entirely. During simulated tail attacks, XP-47K pilots spotted threats an average of 4 seconds earlier than Razorback pilots, enough time to initiate defensive maneuvers that defeated the attack. In multi-aircraft engagements, the bubble canopy's visibility allowed pilots to track multiple threats simultaneously, providing situational awareness that was impossible in the conventional configuration. Colonel Hubert Zemke, commanding the 56th Fighter Group, flew the XP-47K on several evaluation missions and reported back to Republic with unqualified enthusiasm. The visibility improvement was transformational. He could clear his tail section with a simple head turn rather than elaborate weaving maneuvers. He could maintain formation position during weather penetrations without losing sight of lead aircraft. Most importantly, he felt confident that he would see any attacking fighter in time to defend himself. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. But converting test success into production reality required navigating the Army Air Force's procurement bureaucracy. Colonel Francis Griswold, Chief of Fighter Operations for the 8th Air Force, endorsed the bubble canopy concept based on Zemke's evaluation. But procurement officials at Wright Field expressed concerns about production delays, tooling costs, and the risk of introducing major modifications during wartime operations. Some officers argued that improving pilot training in clearing procedures would address the visibility problem without expensive aircraft modifications. Kartveli countered these objections with data from combat loss analysis. Statistical records showed that P-47 pilots were being shot down from rear quarter attacks at rates significantly higher than pilots flying aircraft with better rear visibility. The British Spitfire, with its superior canopy design, suffered rear quarter attack losses at roughly half the rate of P-47 seconds in similar combat environments. American pilots weren't dying from inadequate training. They were dying because their aircraft's design prevented them from seeing threats that should have been survivable. The argument gained support from an unexpected quarter. In October of 1943, a Luftwaffe defector landed his Focke-Wulf 190 at an RAF airfield in England, providing Allied intelligence with detailed information about German fighter tactics and training. Interrogation revealed that Luftwaffe instructors specifically taught new pilots to attack American Thunderbolts from the rear quarter, exploiting the Razorback blind spot. German pilots considered the P-47 vulnerable from behind despite its superior firepower and armor protection. The defector's testimony provided the political ammunition Kartveli needed to force procurement decisions. In November of 1943, the Army Air Forces authorized production of bubble-top P-47 seconds, designating them as a continuation of the D-series rather than creating a new variant letter. The decision reflected pragmatic recognition that the modification was evolutionary rather than revolutionary, improving an existing design rather than creating something entirely new. Republic received authorization to begin production modifications at both the Farmingdale and Evansville facilities, with initial deliveries scheduled for May of 1944. The production challenge was formidable. Both factories would need to retool fuselage assembly lines to accommodate the cut-down configuration. Workers would require training on new structural assembly procedures. Most critically, Republic would need to establish domestic production of bubble canopies, as relying on British suppliers was impractical for the quantities required. The company contracted with several plexiglas manufacturers to develop molds and forming processes that could produce optical quality canopies at production rates matching airframe assembly. The first production bubble-top P-47, designated P-4, 7D-25RE, completed final assembly at Farmingdale in April of 1944. The aircraft incorporated several refinements beyond the experimental XP-47K. Republic's engineers had added a small dorsal fin extension, connecting the vertical stabilizer to the radio mast, restoring some of the directional stability lost when cutting down the fuselage spine. The modification proved highly effective, eliminating the slight yaw oscillation that test pilots had noted in the prototype. Production models also featured improved canopy sealing systems that eliminated the air leaks that had plagued the XP-47K at high altitude. The bubble canopy mounted on a metal rail system that provided both structural support and airtight sealing through multiple rubber gaskets. Emergency jettison systems allowed pilots to blow the canopy off with explosive charges if bailout became necessary, addressing safety concerns about being trapped in an inverted aircraft. The first operational bubble-top P-47 seconds reached England in May of 1944, assigned initially to the 56th Fighter Group based at Boxted. Pilots who transitioned from Razorback aircraft to the new configuration reported immediate appreciation for the improved visibility. Colonel David Schilling described the difference as night and day. He could see everything around his aircraft without the constant head swiveling that had characterized combat in the Razorback. The psychological effect was profound. Pilots felt safer, more aware, and more confident in their ability to survive combat encounters. German pilots noticed the change as well. Intelligence reports documented Luftwaffe communications, referring to a new American fighter variant that seemed impossible to approach undetected from behind. Several German pilots reported attempting standard rear-quarter attacks on Thunderbolts, only to have their targets execute defensive maneuvers before the attacker could achieve firing position. The bubble canopy had eliminated the tactical advantage that Luftwaffe doctrine had exploited for over a year. Combat statistics validated the engineering transformation. Fighter groups equipped with bubble-top P-47 seconds showed measurably lower loss rates from rear-quarter attacks compared to units still flying Razorback variants. The difference wasn't dramatic, perhaps 10 to 15% reduction in overall combat losses, but translated into human terms, it meant dozens of American pilots who survived missions they might not have survived in older aircraft. The improvement came not from better armor or heavier guns, but from the simple ability to see threats in time to react. The transformation extended beyond tactical advantages. Pilots flying bubble-top P-47 seconds reported reduced fatigue during long missions. The constant tension of checking blind spots consumed mental energy that could now be redirected toward mission objectives and threat assessment. Formation flying became less demanding when leaders remained visible through all maneuvers. Navigation over unfamiliar terrain improved when pilots could scan the horizon without fuselage structure blocking their view. Production of bubble-top variants accelerated through summer of 1944, as both Republic factories completed their retooling programs. By July, the company was delivering more than 200 bubble canopy aircraft per month, with production rates climbing steadily as workers mastered new assembly procedures. Razorback production continued in parallel to fulfill existing contracts, but new orders specified bubble-top configuration exclusively. The canopy's appearance also changed fighter recognition training for both American and German pilots. The P-47's distinctive silhouette, previously defined by its Razorback fuselage, now featured a smooth bubble profile that from certain angles resembled the P-51 Mustang. Ground controllers and fighter pilots required updated recognition materials to distinguish between American fighter types at the extended ranges typical of high-altitude combat. The modification illustrated how seemingly simple design changes could cascade through entire operational systems. By September of 1944, nearly every American fighter group in Europe was receiving bubble-top P-47 seconds as replacement aircraft and new unit equipment. The transition created mixed feelings among pilots who had survived dozens of combat missions in Razorback variants. Many felt strong attachment to aircraft that had brought them through harrowing encounters, and switching to a new configuration felt like abandoning a trusted companion. But few pilots voluntarily chose to keep flying Razorbacks once they experienced the bubble canopy's visibility advantages. The engineering success of the P-47's bubble canopy transformation would influence American fighter design for decades afterward. The clear-view canopy became standard on post-war fighters, including Republic's own F-84 Thunderjet, and would eventually appear on virtually every American fighter aircraft. Kartveli's willingness to fundamentally redesign a successful aircraft in response to combat experience established a template for continuous improvement that characterized American aviation development throughout the Cold War. But in late 1944, as Allied armies pushed toward Germany and P-47 Thunderbolts ranged across occupied Europe, the immediate impact was measured in simpler terms. American fighter pilots could see the sky around them. They could track threats. They could survive. Alexander Kartveli's fragile canopy of molded plexiglas had become the difference between life and death at 25,000 feet, proving that sometimes the most important innovations came not from more powerful engines or heavier armament, but from the simple ability to see danger before it killed you. The transformation became visceral for pilots who experienced both configurations in combat. Lieutenant William Bailey, flying with the 353rd Fighter Group, had logged 73 missions in Razorback P-47 seconds before transitioning to a bubble-top aircraft in June of 1944. His first combat sortie in the new configuration occurred during a bomber escort mission to Leipzig, where his formation encountered concentrated Luftwaffe resistance. German fighters attacked from multiple vectors simultaneously, exploiting gaps in the American defensive screen, with tactics refined through years of combat experience. Bailey found himself separated from his flight during the initial engagement, pursuing a Messerschmitt 109 through a diving turn that carried both aircraft through 15,000 feet. The German pilot executed a sharp reversal, attempting to reverse their positions and gain a firing solution on Bailey's Thunderbolt. In a Razorback, Bailey would have lost visual contact during the maneuver, forced to guess his opponent's position based on instinct and experience. But the bubble canopy allowed him to track the 109 throughout the entire sequence, maintaining awareness even as both aircraft pulled G-forces that grayed the edges of his vision. The engagement lasted 47 seconds. Bailey fired 3 bursts, the third connecting with the Messerschmitt's wing root and engine cowling. The German fighter rolled inverted and dove toward the cloud deck below, trailing black smoke. But what struck Bailey most profoundly wasn't the victory itself, but his awareness throughout the engagement. He had seen everything. The attacking fighters diving from above, his wingman breaking left to engage a Focke-Wulf, ground features passing below during his dive, the 109's every movement during their turning fight. Combat had transformed from a partially blind struggle into a fully visual encounter, where information rather than instinct guided split-second decisions. That evening at the officers' club, Bailey tried to explain the difference to pilots still flying Razorback variants. The words felt inadequate. Visibility seemed like an abstract concept until you experienced its absence, and then its presence. One pilot compared it to fighting with one eye closed versus both eyes open. Another suggested it was like removing blinders from a horse. But none of the metaphors captured the psychological transformation. The bubble canopy didn't just improve what you could see, it changed how you thought about combat, eliminating the constant background anxiety of threats developing in blind spots you couldn't check. The engineering required to produce bubble canopies at wartime scale presented challenges that extended far beyond the aircraft themselves. Plexiglas manufacturing in 1944 remained a relatively new industrial process, developed primarily for aircraft windscreens and cockpit glazing. Creating large, single-piece canopies required heating acrylic sheets to precise temperatures, then forming them over carefully machined molds under controlled pressure. The process demanded materials of exceptional optical quality. Even minor imperfections, tiny bubbles or inconsistencies in the acrylic, would distort vision at the precise moments when pilots needed perfect clarity. Rohm and Haas, the primary American supplier of plexiglas, had to expand production capacity specifically to meet Republic's canopy requirements. The company established dedicated forming facilities where workers heated acrylic sheets in massive ovens, then transferred them to hydraulic presses containing canopy molds. The timing was critical. If the acrylic cooled too much before forming, it would crack under pressure. If it remained too hot, it would drape unevenly, creating optical distortions. Master craftsmen monitored each forming operation, adjusting temperatures and pressures based on visual assessment and decades of accumulated experience with acrylic materials. Quality control rejected approximately 15% of formed canopies due to optical imperfections, structural flaws, or dimensional inconsistencies. Each rejected canopy represented wasted materials and labor during a period when both were precious commodities. But Republic insisted on uncompromising standards. A fighter pilot's life depended on seeing clearly through the canopy at altitudes, where temperatures dropped to 40 degrees below zero and air pressure was less than 1/3 sea level values. No compromise on optical quality was acceptable. The canopies themselves required careful handling throughout the manufacturing process. The formed plexiglass was surprisingly fragile before installation, vulnerable to cracking from impact or stress concentration. Workers wore cotton gloves when handling canopies to prevent fingerprints on optical surfaces. Special shipping crates protected the curved surfaces during transportation from plexiglass manufacturers to Republic's assembly facilities. Even minor scratches on the outer surface could scatter sunlight during high-altitude flight, creating glare that interfered with vision at critical moments. Installation procedures required precision that tested even experienced assembly workers. The bubble canopy mounted on a metal rail that ran around its base, connecting to the fuselage through multiple attachment points. Each connection required perfect alignment to distribute loads evenly across the canopy structure. Misalignment created stress concentrations that could cause cracking during flight, particularly during violent maneuvers that imposed G-forces on every aircraft component. Assembly supervisors inspected each installation personally, checking alignment with precision gauges before authorizing the aircraft to proceed down the production line. Sealing systems presented their own engineering challenges. At 25,000 feet, cabin pressure inside the sealed cockpit was artificially maintained at levels equivalent to 10,000 feet altitude, creating significant pressure differential across the canopy structure. Any leak in the sealing system would allow cockpit air to escape, forcing pilots to rely on emergency oxygen systems and potentially causing dangerous decompression. Republic engineers designed multiple redundant seals using different rubber compounds, ensuring that even if one seal failed, backup systems would maintain cockpit integrity. The bubble canopy also required modifications to the P-47's emergency bailout procedures. In razorback aircraft, pilots jettisoned the canopy by releasing mechanical latches, allowing slipstream forces to tear it away from the fuselage. But the larger bubble canopy created significantly more aerodynamic force, making it difficult to jettison through slipstream alone at high speeds. Republic engineers developed small explosive charges that literally blew the canopy away from the aircraft when pilots pulled emergency jettison handles. The system added weight and complexity, but testing proved it could reliably separate the canopy even during inverted flight or high-speed dives. Training programs evolved to address the bubble canopy's unique characteristics. Pilots transitioning from razorback variants received specific instruction on emergency procedures, particularly canopy jettison systems that differed from aircraft they had flown previously. Maintenance crews learned specialized techniques for cleaning optical surfaces without scratching the plexiglass, using specific cleaning compounds and soft cloths that wouldn't damage the material. Ground crews practiced rapid canopy replacement procedures, essential for maintaining operational readiness, when combat damage or structural failures required installing new canopies between missions. The psychological impact of improved visibility extended beyond individual pilot confidence. Fighter tactics evolved to exploit the bubble canopy's advantages, particularly in defensive formations. The traditional four-ship finger four formation had been designed partly to provide mutual visual coverage, with each pilot clearing the tail sections of adjacent aircraft. The bubble canopy allowed more flexible formations where pilots could maintain wider spacing while still clearing each other's blind spots through direct observation rather than coordinated weaving. Major Gerald Johnson, commanding the 9th Fighter Squadron in the Pacific Theater, pioneered new escort tactics that exploited the bubble canopy's visibility advantages during long-range missions over Japanese-held territory. His formations positioned bubble-top P-47 seconds in defensive positions where they could scan for threats across broader sectors than was possible with razorback aircraft. The tactical flexibility proved particularly valuable during extended bomber escorts, where maintaining tight formations for hours consumed fuel and increased pilot fatigue. German pilots adapted their tactics in response to the bubble top. P-47's improved visibility. Luftwaffe training protocols shifted away from rear quarter attacks on Thunderbolts, instead emphasizing head-on passes that exploited the P-47's limited forward visibility over its long nose. These tactics proved moderately effective, but were far more dangerous for German pilots, requiring them to close to point-blank range where the Thunderbolt's devastating firepower could destroy attacking aircraft with single bursts. The tactical shift reflected German recognition that the visibility advantage they had enjoyed for over a year had been eliminated through American engineering innovation. Combat reports from autumn of 1944 documented the bubble canopy's impact through pilot accounts that emphasized psychological rather than tactical effects. Captain Richard Turner, flying with the 354th Fighter Group, described feeling liberated by the visibility. He no longer experienced the claustrophobic sensation that had characterized combat in razorback aircraft. The sky felt open, accessible in every direction. He could track multiple aircraft simultaneously, maintain formation position without constant visual strain, and spot ground features that aided navigation during low-level missions. The transformation proved particularly significant during ground attack operations that increasingly dominated American fighter missions as the Luftwaffe's effectiveness declined. P-47 pilots attacking German transportation networks, supply depots, and troop concentrations faced intense anti-aircraft fire from positions that could approach unseen in razorback aircraft. The bubble canopy allowed pilots to spot flak batteries during approach runs, identify safer attack vectors, and track tracers back to their source positions. Losses to anti-aircraft fire decreased measurably among units equipped with bubble-top variants. Weather operations benefited similarly from improved visibility. Flying through European weather systems that regularly dropped visibility to instrument-only conditions required maintaining formation through clouds, where losing visual contact with lead aircraft could prove fatal. The bubble canopy's superior visibility allowed pilots to maintain visual reference with formation members through conditions that would have forced separation in razorback aircraft. Fewer pilots became lost in weather, reducing both accident rates and the operational inefficiency of scattered formations that had to reform after weather penetrations. The canopy's structural properties created unexpected maintenance challenges that only became apparent after several months of operational use. Plexiglas, while optically superior to glass, was softer and more prone to scratching from wind-blown debris, sand, and general wear. Aircraft operating from forward airfields in France after the Normandy invasion encountered significantly more airborne particulate matter than bases in England, leading to accelerated optical degradation. Maintenance crews developed field procedures for polishing minor scratches using specialized compounds, but deep scratches required complete canopy replacement. Temperature variations also affected canopy longevity. The extreme cold at high altitude caused plexiglas to contract, while sun exposure on the ground caused expansion. This thermal cycling created stress that occasionally led to cracking, particularly around attachment points where the canopy connected to metal framework that expanded and contracted at different rates. Republic engineers continuously refined mounting systems to accommodate thermal movement, adding flexible bushings and improved sealing materials that could accommodate expansion and contraction without creating stress concentrations. Statistical analysis of combat effectiveness proved challenging because multiple factors influenced survival rates beyond canopy configuration. Units receiving bubble-top P-47 seconds in mid-1944 were also benefiting from declining Luftwaffe effectiveness as German fighter strength collapsed under sustained attrition. Fuel shortages limited German training programs, reducing the quality of replacement pilots entering combat. American pilots were accumulating combat experience that improved their effectiveness, regardless of aircraft configuration. Separating the bubble canopy's specific contribution from these broader trends required careful analysis of encounter reports and lost data. The most compelling evidence came from direct comparisons within individual fighter groups during transition periods, when units operated both razorback and bubble-top aircraft simultaneously. The 56th Fighter Group's experience proved particularly informative. During August and September of 1944, the group flew mixed formations with both configurations, allowing direct comparison under identical combat conditions. Bubble-top aircraft showed approximately 12% lower loss rates during missions where both types encountered enemy opposition. The difference wasn't dramatic, but it was consistent across multiple engagements and represented dozens of pilots who survived missions they might not have survived in razorback variants. Pilot preference provided another metric of effectiveness. When given the choice between flying razorback or bubble-top aircraft, pilots overwhelmingly selected bubble-top variants. Several experienced aces, including Francis Gabreski and Robert Johnson, transitioned to bubble canopy P-47 seconds, despite their success in razorback aircraft. Their willingness to change aircraft mid-tour spoke volumes about the perceived advantages of improved visibility. These were pilots whose lives depended on their aircraft's capabilities, and they voted unanimously for better visibility. The bubble canopy's success influenced thinking about fighter design that extended beyond World War II. Post-war American fighters universally adopted clear-view canopies, with engineers accepting as axiomatic that maximum visibility was non-negotiable. The North American F-86 Sabre, Lockheed F-80 Shooting Star, and Republic's own F-84 Thunderjet all featured bubble canopies from their initial designs. The concept that had seemed risky and experimental in 1943 became standard practice within 5 years. International recognition of the bubble canopy's advantages appeared in post-war Soviet fighter designs. Stalin's aviation designers studied captured P-47 seconds equipped with bubble canopies, incorporating similar features into next-generation Soviet fighters. The MiG-15 and La-15 both featured clear-view canopies that owed clear lineage to American innovations. The technology transfer illustrated how combat effectiveness, rather than ideology, drove aeronautical development during the early Cold War period. Alexander Kartveli continued refining fighter design through Republic's post-war projects, always prioritizing pilot visibility in his engineering calculations. The F-84 Thunderjet featured an even more advanced canopy design, with thinner framing and larger optical surfaces than the P-47's bubble canopy. His F-105 Thunderchief incorporated a massive clamshell canopy that provided visibility exceeding any previous fighter design. The A-10 Thunderbolt II, Kartveli's final major project before retirement, positioned the pilot under a massive bubble canopy that offered unparalleled visibility for low-altitude ground attack missions. His commitment to protecting pilots through superior visibility remained constant throughout his career. The material science that made bubble canopies possible continued advancing throughout the post-war period. Improved acrylic formulations offered better scratch resistance and optical qualities. Polycarbonate materials developed in the 1960s provided impact resistance impossible with standard Plexiglas. Modern fighter canopies incorporate multiple layers of materials optimized for optical quality, structural strength, and protection against bird strikes at high speeds. But the fundamental principle established by the P-47's bubble canopy remained unchanged. Giving pilots unobstructed visibility in all directions was worth significant engineering investment and production complexity. Training philosophies also evolved in recognition of the visibility advantages modern canopies provided. Fighter tactics instruction emphasized visual scanning patterns that exploited clear-view canopies, teaching pilots systematic search techniques that covered entire hemispheres rather than just forward sectors. Simulator training incorporated detailed visibility modeling, allowing student pilots to practice scanning techniques before flying actual aircraft. The emphasis on visual awareness that bubble canopies enabled became foundational to fighter pilot training worldwide. The human cost of the Razorback's visibility limitations could never be precisely calculated. How many pilots died in early P-47 seconds because they couldn't see attacking fighters in time to react? The question had no definitive answer. Combat loss records documented causes of death when they could be determined, but many pilots simply disappeared during missions, their aircraft falling into the sea or crashing in remote areas where no witnesses survived. Some percentage of those losses certainly resulted from attacks developing in blind spots that better visibility might have revealed in time to save lives. But the lives saved by the bubble canopy's introduction were equally difficult to quantify. Statistical analysis suggested that several hundred American pilots survived missions in bubble-top P-47 seconds that might have killed them in Razorback variants. The number was significant, but relatively small compared to the tens of thousands of pilots who flew Thunderbolts during World War II. Yet for those several hundred pilots, and for their families who welcomed them home after the war, the bubble canopy represented the difference between life and death. The engineering achievement also illustrated broader principles about military innovation during wartime. The bubble canopy succeeded not because it represented cutting-edge technology or radical scientific breakthrough, but because it solved a specific, well-documented problem through careful engineering and willingness to modify proven designs. The solution required overcoming institutional inertia, accepting significant production complications, and trusting that combat effectiveness would justify the investment. The success validated an approach to military development that prioritized operational requirements over production convenience. The story also demonstrated the importance of feedback loops between combat operations and engineering development. The bubble canopy emerged directly from pilot complaints and combat loss analysis. Engineers received detailed information about tactical problems, understood their root causes, and developed solutions targeted at specific operational failures. This iterative process, where combat experience directly shaped engineering priorities, characterized American aviation development throughout World War II and established patterns that continued through subsequent conflicts. Material suppliers who produced plexiglas for bubble canopies gained expertise that benefited civilian applications after the war. The precision forming techniques developed for military canopies transferred directly to civilian aircraft, automobile windshields, and architectural applications, where large, curved, transparent surfaces provided functional and aesthetic benefits. The industrial capacity built to support military production during wartime found peacetime applications that advanced multiple industries simultaneously. The workers who assembled bubble-top P-47 seconds carried memories of their contributions throughout their lives. Many spoke later about the pride they felt knowing their work protected American pilots. Factory workers understood that careless assembly or inadequate quality control could cost lives. That knowledge created motivation that transcended normal industrial employment. The bubble canopy represented not just a production challenge, but a moral responsibility to the men who would depend on it at 25,000 feet over enemy territory. Veterans who flew bubble-top P-47 seconds remembered the aircraft with affection mixed with respect. The Thunderbolt was never an easy aircraft to fly. Its size and weight demanded constant attention and considerable physical strength to manage during violent combat maneuvers. But pilots trusted it. They knew it would absorb punishment, maintain flight even with severe damage, and give them the visibility they needed to see threats and opportunities. The bubble canopy completed the package, transforming a capable fighter into a comprehensive combat system. The canopy's development timeline illustrated how quickly American industry could respond to wartime requirements when properly motivated. From Kartveli's initial recognition of the problem in spring of 1943 to production deliveries in May of 1944 took just over 1 year. That timeline included conceptual design, prototype construction and testing, procurement approval, production tooling, worker training, and manufacturing ramp-up. The speed reflected both the urgency of wartime requirements and the flexibility of American industrial capacity during World War II. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.